So good evening. My name is Vanja Mileski, and I come from the Josef Stefan Institute in Slovenia. Today I will talk about multidimensional analysis of PPMI data. I'm sure that many of you have heard and know about the Parkinson's disease, and as you know, it is an irreversible and incurable disease that affects the body movement of the patients. PPMI in the title stands for Parkinson's Progression Markers Initiative, and it's an observational study of clinical research on Parkinson's disease on studies performed worldwide. So I use data provided by them, and the goal is to predict multiple motor assessment scores of the patients and try to describe them using data from MRIs, fMRI scans, and also DET scans. So using data mining techniques, we are trying to describe 35 motor assessment scores. These scores go from 0 to 4, and they tell us how much the patients are shaking or have tremors in their arms, legs, facial expression, speech, and similar. So we are trying to predict all 35 scores at once. We want to predict them, so they are our target, and our descriptive features are fMRI features, or more precisely, regions of interest of the brain. So those are volumes of certain regions in the patient's brain, and also from DET scans, those are dopamine transporter scans. The technique that was used for the data mining process is called predictive clustering trees. Now, as the name suggests, predictive clustering means that we are using both prediction and clustering. So we try to find similar groups of patients and try to fit a model on those groups, those clusters. And you can see predictive clustering trees as a generalization of the normal decision trees for predicting structured outputs. Now, we can do this predictions, this data mining in several ways. So we can try to predict all of the 35 scores at once. We can try to predict each score one by one, and we can also try to group them. We can group them either by the default grouping, for example, hands in one group, legs in other, facial expression in the third, or we can try to group them by side of the body. For example, all of the features from the left side of the body in one group, and all of the right features in the other group. The best, after the tests were done on all of the groupings, and the best one was when we tried to predict all of the scores at once. And we got this is a pruned tree from the results from the predictive clustering trees when you try to predict all of the scores at once, so the entire vector of 35 motor scores. And as you can see, many of the, on top of the tree, we have putamen and also codet, which is not shown in this picture, which corresponds with many clinical medical studies done on Parkinson's disease, which show that on these parts in the brain there is, at least if nothing else, changes at people that are sick of the Parkinson's disease. We also used ensembles of predictive clusterings. Those are Bayesian or random forest to boost the predictive power, which we got it to 73%. And with future work, we hope that we will be able to, boost this accuracy even higher. So you're welcome to ask any questions that you might have at the poster session later. Thank you.